Theory of Colors is a book by Johann Wolfgang von Goethe about the poet's views on the nature of colors and how these are perceived by humans. Published in 1810, it contains detailed descriptions of phenomena such as colored shadows, refraction, and chromatic aberration. The work originated in Goethe's occupation with painting and mainly exerted an influence onto the arts. Although Goethe's work was rejected by physicists, a number of philosophers and physicists have concerned themselves with it, including Thomas Johann Seebeck, Arthur Schopenhauer, Hermann von Helmholtz, Rudolf Steiner, Ludwig Wittgenstein, Werner Heisenberg, Kurt Gödel, and Mitchell Feigenbaum. Goethe's book provides a catalogue of how color is perceived in a wide variety of circumstances, and considers Isaac Newton's observations to be special cases. Unlike Newton, Goethe's concern was not so much with the analytic treatment of color, as with the qualities of how phenomena are perceived. Philosophers have come to understand the distinction between the optical spectrum, as observed by Newton, and the phenomenon of human color perception as presented by Goethe, a subject analyzed at length by Wittgenstein in his exegesis of Goethe in Remarks on Color. Historical background. At Goethe's time, it was generally acknowledged that, as Isaac Newton had shown in his Optics in 1704, colorless light is split up into its component colors when directed through a prism. Along with the rest of the world, I was convinced that all the colors are contained in the light. No one had ever told me anything different, and I had never found the least cause to doubt it, because I had no further interest in the subject. But how I was astonished, as I looked at a white wall through the prism, that it stayed white. That only where it came upon some darkened area, it showed some color. Then at last, around the windowsill all the colors shone. It didn't take long before I knew here was something significant about color to be brought forth, and I spoke as through an instinct out loud, that the Newtonian teachings were false. Goethe's starting point was the supposed discovery of how Newton erred in the prismatic experiment, and by 1793 Goethe had formulated his arguments against Newton in the essay über Newtons Hypothese der diversen Refrangibilität. Yet, by 1794, Goethe had begun to increasingly note the importance of the physiological aspect of colors. As Goethe notes in the historical section, Louis Bertrand Castellou had already published a criticism of Newton's spectral description of prismatic color in 1740, in which he observed that the sequence of colors split by a prism depended on the distance from the prism, and that Newton was looking at a special case. Whereas Newton observed the color spectrum cast on a wall at a fixed distance away from the prism, Goethe observed the cast spectrum on a white card which was progressively moved away from the prism. As the card was moved away, the projected image elongated, gradually assuming an elliptical shape, and the colored images became larger, finally merging at the center to produce green. Moving the card farther led to the increase in the size of the image, until finally the spectrum described by Newton in the Optics was produced. The image cast by the refracted beam was not fixed, but rather developed with increasing distance from the prism. Consequently, Goethe saw the particular distance chosen by Newton to prove the second proposition of the Optics as capriciously imposed the theory we set up. Against this begins with colorless light, and avails itself of outward conditions, to produce colored phenomena, but it concedes worth and dignity to these conditions. It does not arrogate to itself developing colors from the light, but rather seeks to prove by numberless cases that color is produced by light as well as by what stands against it. Goethe. In the preface to the Theory of Colors, Goethe explained that he tried to apply the principle of polarity in the work, a proposition that belonged to his earliest convictions and was constitutive of his entire study of nature. Goethe's theory. Nothing can be predicted with it. It is, rather, a vague schematic outline of the sort we find in James's psychology. Nor is there any experimentum crucis which could decide for or against the theory. Ludwig Wittgenstein, Remarks on Color, paragraph 70. It is hard to present Goethe's theory, since he refrains from setting up any actual theory. He says, its intention is to portray rather than explain. Instead of setting up models and explanations, Goethe collected specimens. He was responsible for the meteorological collections of Jena University. By the time of his death, he had amassed over 17,800 minerals in his personal collection, the largest in all of Europe. He took the same approach to color. Instead of narrowing and isolating things to a single experimentum crucius, he sought to gain as much breadth for his understanding as possible by developing a wide range of interrogations through which he would reveal the essential character of color, without having to resort to explanations and theories about perceived phenomena such as wavelengths or particles. The crux of his color theory is its experiential source, rather than impose theoretical statements. Goethe sought to allow light and color to be displayed in an ordered series of experiments that readers could experience for themselves. According to Goethe, Newton's error was trusting math over the sensations of his eye. To stay true to the perception without resort to explanation was the essence of Goethe's method. What he provided was really not so much a theory, as a rational description of color. For Goethe, the highest is to understand that all fact is really theory. The blue of the sky reveals to us the basic law of color. Search nothing beyond the phenomena. They themselves are the theory. Goethe delivered in full measure what was promised by the title of his excellent work, Data for a Theory of Color. They are important, complete, and significant data, rich material for a future theory of color. He has not, however, undertaken to furnish the theory itself. Hence, as he himself remarks and admits on page XXXIX of the introduction, he has not furnished us with a real explanation of the essential nature of color, but really postulates it as a phenomenon, and merely tells us how it originates, not what it is. The physiological colors he represents as a phenomenon, complete and existing by itself, without even attempting to show their relation to the physical colors. His principal theme. It is really a systematic presentation of facts, but it stops short at this. Schopenhauer, on Vision and Colors, Introduction. Goethe outlines his method in the essay, The Experiment as Mediator between Subject and Object. It underscores his experiential standpoint. The human being himself, to the extent that he makes sound use of his senses, is the most exact physical apparatus that can exist. I believe that what Goethe was really seeking was not a physiological but a psychological theory of colors. Ludwig Wittgenstein, Culture and Value, MS 112255-26, 11.1931. Light and darkness. Unlike his contemporaries, Goethe didn't see darkness as an absence of light, but rather as polar to and interacting with light. Color is altered from this interaction of light and shadow. For Goethe, light is the simplest, most undivided, most homogeneous being that we know. Confronting it is the darkness. They maintained that shade is a part of light. It sounds absurd when I express it, but so it is. For they said that colors, which are shadow and the result of shade, are light itself. Johann Eckermann, Conversations of Goethe, entry, January 4, 1824, trans. Wallace Wood. Based on his experiments with Turbid Media, Goethe characterized color as arising from the dynamic interplay of darkness and light. Rudolf Steiner, the science editor for the Kirchner edition of Goethe's works, gave the following analogy. Modern natural science sees darkness as a complete nothingness. According to this view, the light which streams into a dark space has no resistance from the darkness to overcome. Goethe pictures to himself that light and darkness relate to each other like the north and south pole of a magnet. The darkness can weaken the light in its working power. Conversely, the light can limit the energy of the darkness. In both cases, color arises. Rudolf Steiner, 1897. Goethe expresses this more succinctly. Yellow is a light which has been dampened by darkness. Blue is a darkness weakened by light. Experiments with turbid media. The action of turbid media was to Goethe the ultimate fact, the phenomenon, of the world of colors. John Tyndall, 1880. Goethe's studies of color began with experiments which examined the effects of turbid media, such as air, dust, and moisture on the perception of light and dark. The poet observed that light seen through a turbid medium appears yellow, and darkness seen through an illuminated medium appears blue. The highest degree of light, such as that of the sun, is for the most part colorless. This light, however, seen through a medium but very slightly thickened, appears to us yellow. If the density of such a medium be increased, or if its volume become greater, we shall see the light gradually assume a yellow-red hue, which at last deepens to a ruby color. If on the other hand darkness is seen through a semi-transparent medium, which is itself illumined by a light striking on it, a blue color appears. This becomes lighter and paler as the density of the medium is increased, but on the contrary appears darker and deeper the more transparent the medium becomes. In the least degree of dimness short of absolute transparence, always supposing a perfectly colorless medium, this deep blue approaches the most beautiful violet. Goethe, Theory of Colors, pp. 150–151. He then proceeds with numerous experiments, systematically observing the effects of rarefied mediums such as dust, air, and moisture on the perception of color. Boundary conditions when viewed through a prism. The orientation of a light-dark boundary with respect to the prism's axis is significant. With white above a dark boundary, we observe the light extending a blue-violet edge into the dark area, whereas dark above a light boundary results in a red-yellow edge extending into the light area. Goethe was intrigued by this difference. He felt that this arising of color at light-dark boundaries was fundamental to the creation of the spectrum. Varying the experimental conditions by using different shades of gray shows that the intensity of colored edges increases with boundary contrast. Light and dark spectra. Since the color phenomenon relies on the adjacency of light and dark, there are two ways to produce a spectrum: with a light beam in a dark room, and with a dark beam in a light room. Goethe recorded the sequence of colors projected at various distances from a prism for both cases. In both cases, he found that the yellow and blue edges remain closest to the side which is light, and red and violet edges remain closest to the side which is dark. At a certain distance, these edges overlap, and we obtain Newton's spectrum. When these edges overlap in a light spectrum, green results. When they overlap in a dark spectrum, magenta results. With a light spectrum, we find yellow-red colors along the top edge, and blue-violet colors along the bottom edge. The spectrum with green in the middle arises only where the blue-violet edges overlap the yellow-red edges. With a dark spectrum, we find violet-blue along the top edge, and red-yellow along the bottom edge, and where these edges overlap, we find magenta. Goethe's color wheel. When the eye sees a color it is immediately excited, and it is its nature, spontaneously and of necessity, at once to produce another, which with the original color, comprehends the whole chromatic scale. Goethe, Theory of Colors. Goethe anticipated Abel Herring's opponent process theory by proposing a symmetric color wheel. He writes, "The chromatic circle is arranged in a general way according to the natural order, for the colors diametrically opposed to each other in this diagram are those which reciprocally evoke each other in the eye. Thus, yellow demands violet, orange demands blue, purple demands green, and vice versa. Thus, all intermediate gradations reciprocally evoke each other, the simpler color demanding the compound, and vice versa. In the same way that light and dark spectra are yielded green from the mixture of blue and yellow." Goethe completed his color wheel by recognizing the importance of magenta. For Newton, only spectral colors could count as fundamental. By contrast, Goethe's more empirical approach led him to recognize the essential role of magenta in a complete color circle, a role that it still has in all modern color systems. Complementary colors and color psychology. Goethe also included aesthetic qualities in his color wheel, under the title of allegorical, symbolic, mystic use of color, establishing a kind of color psychology. He associated red with the beautiful, orange with the noble, yellow to the good, green to the useful, blue to the common, and violet to the unnecessary. These 6 qualities were assigned to 4 categories of human cognition: the rational to the beautiful and the noble, the intellectual to the good and the useful, the sensual to the useful and the common, and closing the circle, imagination to both the unnecessary and the beautiful. Notes on translation. Magenta appeared as a color term only in the mid-19th century, after Goethe. Hence, references to Goethe's recognition of magenta are fraught with interpretation. If one observes the colors coming out of a prism, an English person may be more inclined to describe as magenta what in German is called purpur, so one may not lose the intention of the author. However, literal translation is more difficult. Goethe's work uses 2 composite words for mixed hues along with corresponding usual color terms such as orange and violet. It is not clear how Goethe's rot, purpur, and shorn are related between themselves and to the red tip of the visible spectrum. The text about interference from the physical chapter does not consider rot and purpur synonymous. Also, purpur is certainly distinct from blaurot, because purpur is named as a color which lies somewhere between blaurot and gelbrot, although possibly not adjacent to the latter. This article uses the English translations from the above table. Newton and Goethe. The essential difference between Goethe's theory of color and the theory which has prevailed in science since Newton's day lies in this. While the theory of Newton and his successors was based on excluding the color-seeing faculty of the eye, Goethe founded his theory on the eye's experience of color, the renouncing of life and immediacy, which was the premise for the progress of natural science since Newton, formed the real basis for the bitter struggle which Goethe waged against the physical optics of Newton. It would be superficial to dismiss this struggle as unimportant. There is much significance in one of the most outstanding men directing all his efforts to fighting against the development of Newtonian optics, due to their different approaches to a common subject. Many misunderstandings have arisen between Newton's mathematical understanding of optics and Goethe's experiential approach. Because Newton understands white light to be composed of individual colors, and Goethe sees color arising from the interaction of light and dark, they come to different conclusions on the question: is the optical spectrum a primary or a compound phenomenon? For Newton, the prism is immaterial to the existence of color, as all the colors already exist in white light, and the prism merely fans them out according to their refrangibility. Goethe sought to show that, as a turbid medium, the prism was an integral factor in the arising of color, whereas Newton narrowed the beam of light in order to isolate the phenomenon. Goethe observed that with a wider aperture, there was no spectrum. He saw only reddish-yellow edges and blue-cyan edges with white between them, and the spectrum arose only where these edges came close enough to overlap. For him, the spectrum could be explained by the simpler phenomena of color arising from the interaction of light and dark edges. Newton explains the appearance of white with colored edges by saying that due to the differing overall amount of refraction, the rays mix together to create a full white towards the center, whereas the edges do not benefit from this full mixture and appear with greater red or blue components. For Newton's account of his experiments, see his Optics. Table of differences. Goethe's reification of darkness is rejected by modern physics. Both Newton and Huygens defined darkness as an absence of light. Physicists today attribute both a corpuscular and undulatory character to light, comprising the wave-particle duality.